Welcome to this GCSE Science tutorial video on mixtures. For great GCSE Science content, be sure to subscribe and remember to check us out on TikTok, where we post GCSE Science videos daily. A mixture is two or more elements or compounds not chemically bonded. And because the elements or compounds in a mixture are not chemically bonded, it means a mixture can be separated into the elements and or compounds it is made up of. This means that the properties of the elements and compounds that make up the mixture remain unchanged. Please remember, this is a really important point, there are no chemical bonds between the substances within the mixture. Appearing on the screen now is a particle diagram that shows a mixture of gases. Let's go and label the different components of this mixture now. The first, here we have a compound, two different types of atom. This is ammonia with the chemical formula NH3. Next up we have another compound here. This is carbon monoxide with the chemical formula CO. And lastly here we have the element helium with the chemical formula He. So then if we separated out the gases from the mixture, they would all have their original properties. So ammonia here would still have a very strong odour. In other words, it would be very smelly. Carbon monoxide would still be colourless and toxic. And helium would still be unreactive. There are a number of different ways you can separate mixtures, and they should be somewhat familiar to you from years 7 and 8. However, here's a brief summary before we delve into more detail later in the video. So the first, filtration, the separation of an insoluble solid from a solution. Now, the word insoluble means that a substance is unable to dissolve. So let's take the classic example of separating out rock salt. The insoluble solid here would be the rock, or when that rock is ground up, it would be sand, with the solution being salt from the rock salt and water. And the water we would call the solvent, and the salt we would call the solute. So in summary here, filtration will be used to separate rock and sand from a salt solution. Next up we have evaporation and crystallization, and these methods separate a soluble solid from a solution. Now, soluble is the opposite of insoluble. Soluble means able to dissolve. So sticking with our current rock salt example, evaporation and crystallization would allow us to separate out salt, the soluble solid, from the saltwater solution. However, another example of a soluble solid that could be separated from a solution would be sugar from the water. Next up we have simple distillation, and this method separates a liquid from a solution. This would be used to maybe separate ink from ink and water mixture. And in simple distillation, the liquid with the lowest boiling point will evaporate first. Another method for separating mixtures is fractional distillation, where we separate a liquid mixture into its different components. Fractional distillation is useful for separating a liquid mixture when the components have similar boiling points. And just like simple distillation, the substance with the lowest boiling point will evaporate first. And the last method for separating mixtures that you need to know about is chromatography. And chromatography separates two or often more dissolved solids within a solution. In fact, chromatography can not only separate dissolved solids, but also liquids. For example, food colorings, inks, and even drugs. Remember, I've just outlined the basics of these methods for separating mixtures. Now we're going to look at each individual method in a lot more detail. So we start back again with filtration. I will now go through and label for you the sort of typical apparatus needed to carry out filtration. So first of all we have the filter funnel here, and in here, so it's not the most visible on this diagram, we have the filter paper. Here we have the beaker, and you can see here we have our sand, and you can see here the sand is mixed in with some seawater in this case. So let's explain how to carry out filtration. Well, step number one, first of all, we have to pour the sand and seawater mixture into the filter funnel containing the filter paper. Now, for part two here, we need to be aware of the fact that the sand particles or the sand grains are too large to fit through the paper holes. However, the salt and water particles are very, very small, so they fit through the holes in the filter paper, so pass through. That means then that in the beaker we have a salt water solution. And this salt water solution we call the filtrate. And any remaining sand trapped by the filter paper is called the residue. Okay, so let's say now we want to remove the water from our saltwater solution to obtain the salt. We can transfer the salt water to an evaporating dish. Then we could simply leave our saltwater solution at room temperature, and this means the water evaporates slowly. And the longer we leave the solution, the larger salt crystals will form, and we call this formation of crystals crystallization. The alternative to leaving your salt solution at room temperature for the water to evaporate is to cause the water to evaporate at a much faster rate using a Bunsen burner. Using this alternative method, you would still obtain salt. However, the crystals will be much smaller, or they may just simply be grains. We will now be describing simple distillation in a lot more detail. Appearing on the screen now is all the equipment needed for simple distillation. This rounded flask here is called a distillation flask. And for this example here, the mixture that's going to be separated is a mixture of ethanol and water. Then, to separate this mixture, the solution would then be heated. This can be from a Bunsen burner or another heat source such as an electric heater. And remember here, the substance with the lowest boiling point will evaporate first and move up the flask. You could also say that that substance has vaporized, as in become a gas. So the vapor will then travel up the flask and it will reach this next piece of equipment called a Liebig condenser. The Liebig condenser actually cools down the vapor because there's water flowing in there and out here. And what this does is create a jacket of cool water, and the vapor then condenses into a liquid. So the liquid in the beaker is the liquid with the lowest boiling point, which in this example is ethanol at 68 degrees Celsius. Leaving water in the flask, which has a boiling point of 100 degrees Celsius. There is a fairly big disadvantage of using simple distillation to separate mixtures. And that is when boiling points are very close, substances can mix again once they condense. Now on to fractional distillation. Appearing on your screen now is the equipment needed to carry out the fractional distillation of crude oil in a school lab. In reality, this would really be done at an oil refinery. Labelling then, this piece of equipment here is known as a fractionating column. And contained within the fractionating column here are glass rods. And these glass rods are there to ensure separation of the different components in the mixture that we call fractions. It is cooler at the top of the fractionating column and hotter at the bottom, and this temperature difference is what we call a temperature gradient. It is hotter at the bottom of the fractionating column because there it is closer to the heat source that is heating our crude oil mixture. And just like simple distillation, we have the Liebig condenser collected up. Now, I haven't been completely honest here. In a school setting, you wouldn't actually heat crude oil. So it is not crude oil there in the bottom in reality. It is something called crude oil substitute. It behaves just like crude oil, but it's not as toxic or bad for the environment. As for carrying out fractional distillation of crude oil substitute, you have to make sure that the crude oil substitute is heated. Secondly, the different fractions, that's the liquids, shown in the first three tubes here, here and here, separate out at different temperatures. And these temperatures are the different boiling points. So the tube furthest left contains the fraction with the lowest boiling point, and the tube second from the right contains the fraction with the highest boiling point. It is important to note that the temperature of the mixture can only be increased once the fraction has been collected. Otherwise, fractions with high boiling points may condense at the top of the fractionating column where it will be cooler. And this can result in the liquid being dropped back into the flask, which means the mixture hasn't been properly separated. Lastly, we have a bit more detail on chromatography. So here is the basic setup for chromatography in order to separate multiple dissolved substances from a mixture. And this method of basic chromatography is known as paper chromatography. Here we have a beaker, or you could use any sort of container for this. In the beaker at the bottom here we have the solvent, which in this case is water. However, different types of alcohols can be used as solvents because some substances dissolve better in non-water based solvents. Here we have chromatography paper, which is just a type of filter paper. We also have to draw something called a baseline, which is labelled here. The baseline is drawn around 1 to 2 centimeters from the bottom of the paper. It is also drawn in pencil. This is because graphite, the material inside a pencil, is insoluble in water and any other solvent for that matter. Let's assume for this example we are separating out black felt tip penning, which is soluble in water. So a spot of black ink is placed on the baseline. Obviously this is done before placing the chromatography paper in the water. Now the water must not touch the ink, otherwise it would dissolve straight into the water. Notice there is a gap so the water can travel up the paper. Imagine then from this point now we have the water travelling up the paper. We would see the black ink separate out into the different dyes that it is made up of. Explaining these results then, the more soluble dyes in the ink travel further up the paper. And any substances that are insoluble in water will stay on the baseline. In this case, we don't have any insoluble substances. As the water gets close to the top of the paper, you can remove it and look at your result. What you can see here with the blue, pink and yellow spots is called a chromatogram. And from this chromatogram we can see that the blue dye is the most soluble, with the yellow dye being the least soluble in the water. Remember that the more soluble a substance is, the further the water is going to carry it up the paper. And we can now rank them: blue number 1, pink number 2, yellow number 3. We can also say that the black ink is a mixture that contains blue dye, pink dye and yellow dye. We have now reached the end of this video on mixtures. Thank you once again for choosing Genius Science. Remember to work hard at whatever it is you do, be kind to others, and we'll see you in the next video. Take care.